Hello everyone, my name is Erik Kuefler. I'm a software engineer at Google. I don't actually work on the GWT team itself, but I've been working on Google Wallet since about 2011. Before that, I've worked on various other GWT applications going back to around 2009 or so. And in that time, one of my big focuses has been on improving the testability of our applications and making sure we can run very comprehensive automated tests against all of our applications. So I want to talk to you about some strategies for doing that. And when I'm talking about testing GWT applications, or really any sort of web application, there's really two kinds of tests that we might think about running, both of which are referred to by various names. So the first are your relatively small level your small tests, your unit tests, things that actually run against your code, against your API directly. So these are tests that confirm individual methods or individual classes inside your application. And the motivation you have for writing these, one of the largest ones, is to allow you to develop quickly. So starting up your entire GWT application just to test one little change might take a few minutes, which is time you might not want to spend. So when I'm developing, I tend to have a comprehensive suite of unit tests against my class, and I run those tests very frequently, maybe as often as a couple times per minute. That's really convenient when I'm developing because it means I can see the effect of every change I make, and I can know right away if something I've changed has broken something. So the advantage to these unit tests are they're very fast to run and very well focused, so I can tell exactly what's going on in my code at any time. Then on the other end, you have what's referred to as functional tests or end-to-end tests or integration tests, which actually stress your system all the way through and verify that it really works according to how a user would see it. So the difference here is that rather than calling the methods in your code and testing it as Java code or as JavaScript, you're going through and testing like a user, where you actually go through and tell it to click on a button or type into a text field or so on and so forth. These aren't going to be as fast as your smaller tests, so they aren't things you're running continually. But the big advantage they provide you is that they're very thorough, and they provide you with great confidence that your application actually works end to end. And when a user goes through it, they won't see errors all over the place. So these tests are both very valuable. You should have both of these kinds, and this presentation is going to be split into two sections. First, where I talk about techniques for the first small kind of test, and second, where I talk about larger tests. So let's get started talking about unit tests. So as I said, a unit test is something that tests a single component of your code, a single unit. There's always a little bit of variation on what exactly you define a unit as. Sometimes it's a single class or method. Sometimes it's a class and its closely related dependencies. But the idea here is you're testing the actual methods and classes in your application. The fact that you are writing these very focused tests means that you need to have a way to fake out or mock out everything that you aren't actually testing in the test you're writing itself. So one of the most obvious examples here is if you're just testing some small component of your UI, you don't want to have to in your test make a bunch of real calls against your server and start up that and wait for the network latency and everything. So what you do instead is to have some way to create fake versions of those servers such that you don't have to depend on them in your tests. And the motivation for doing this, as I said, is so you can run your tests very quickly, probably just bind them to a single keystroke in Eclipse so you can call them up at any time you need. Before I get started talking about my testing strategy too much, I want to talk about GWT.TestCase, which is the unit testing strategy that is basically built into GWT. So GWT.TestCase has a lot of advantages. How it works, how you're probably familiar with, is GWT.TestCase will actually take what you've written as a JUnit test and do a full compilation down to GWT, down to JavaScript, such that you're running an actual GWT application as part of your test using a fake browser. And this is good. It gives you a fairly realistic end-to-end test, but the big problem in using GWT.TestCase and doing this compilation is that it's very slow. So once you go through and you do your GWT compilation and you start up this headless browser, that can take as much as 30 seconds just to run a trivial test of a trivial application. And of course, it gets even longer than that as your tests get more interesting. So I said in the startup here that I often like to run my tests multiple times per minute, and so if it's going to take me 30 seconds to run any given test, that completely blows this out of the water as an ideal option. Another problem we have with GWT.TestCase is that you don't have a lot of your standard Java tools available. So a lot of testing tools built into Java rely on reflection. So if you're using a mocking framework like Mockito, you need to have reflection and other features built into Java available. But once you've gone through and compiled down to JavaScript, you don't have that kind of stuff available. I should say as a side note that if you are looking for a mocking framework that looks in GWT.TestCase, there's a cool one called Easy GWT out there that you can take a look at. It's not quite as powerful as normal Java mocking frameworks, and it's a little more verbose because it has to work under these constraints, but it is an option. So considering these downsides, when I'm writing these kind of tests, I tend to try as much as possible to test my code directly as if it were Java code. Just writing normal JUnit tests, executing it directly, and not going through the GWT compilation steps at all. All that being said, GWT.TestCase, of course, isn't useless. There's a lot of places where it's the right thing to do. The best examples are when you need to test code that relies very heavily on JS&I, because there you actually do need to execute that JavaScript. And if you're testing code that relies very heavily on manipulating the DOM. If you have simple incidental DOM operations, you're just pulling things into and out of text fields. You don't need to go to GWT.TestCase, but if you're doing things that actually depend on relying on how the browser works and complex behavior there, sometimes this can be better. So you shouldn't avoid this completely, but generally GWT.TestCase should not be your first choice if you want to write fast and reliable tests. So let's take a look at the kind of code you might want to test inside your GWT application. So here I have a fairly simple widget. This is an email field. All it really does is it wraps around a text box and a label. So you type into that text box, you press a button to save your email address. It validates against a regular expression, then calls out to the server to save it, and updates the message in the UI. So this is a really simple class. It might, as it is here, it might be too simple to even bother writing tests for, but it does illustrate a lot of things we might want to do inside a GWT application and some of the problems we might run into when trying to write tests. So let's step through those problems one by one. So the first thing you see at the top here is that we are relying on these external dependencies that are defined by GWT and not necessarily going to be available to us. So first thing is are these UI fields here, these widgets. So normally if you have a widget, you annotate it with UI field, you're going to go and run a UI binder. It's going to create instances for these for you, associate them with widgets in the DOM, and so forth. So here, if we're running this as purely Java code, we don't have a DOM available, there's no browser, and we don't know where these UI fields are going to come from. That's one thing we have to work around. And then going in the other direction, we have this service we're relying on. So you can see here that I'm calling GWT.create. And if you've ever tried to call GWT.create in unit test code, you've probably run into some horrible error that says GWT.create can't be called from server-side code. You need to go use GWT.TestCase for your unit tests, which you don't want to do. So we need to find a way both to make GWT.create work and for it to return us some fake version of this service that we can control in testing. Once we have our instances available, we also need to figure out how to actually perform this button click here that would normally be handled by UI binder. So again, if we're using UI binder, we have this UI handler annotation here. It would say find a button in the DOM and invoke this handler when that button is clicked. If we're running Java, we don't have a DOM, we don't have buttons, we don't have a UI binder to set these up, so we need an alternate way to perform a button click. Next, looking at the actual usage of these widgets themselves. So once you've just gotten a reference to them, if we were able to fake out those UI fields somehow, we're not done. So normally when we call .getText on this text box here, we would be reading from this text field and trying to figure out what the user had actually typed into the box. We won't have a real text field, so we need to program our widget to say what it's going to actually return from its getText method. And then going the other direction, normally if you called set text on a label like here, we'd go insert some text into the DOM. If we have no DOM, we need to verify that this text was actually set in the way we expect. And then we have the same problems looking back at the server. So the server, normally you invoke it with this async callback, and it'll invoke that eventually. We need a way to be able to tell the server both it should return with success with certain arguments, or it should return with failure. And then we also need to confirm that the server was used in the way we expect. So this is a really simple class, and that's a lot of problems right off the bat. You'll see right away they really fall into one of two categories. We need to have a mock browser, a fake browser of some sort, and we need to have some sort of fake server, because those are the two major components that really aren't available to us when we're testing this as pure Java code. And so if you've done much work in writing Java unit tests, at some point you've probably encountered the idea of a mocking framework. So how a mocking framework works is you tell the framework basically, okay, give me a fake version of some instance of a class. And then when you interact with that class, you tell that mock class to say, when I invoke this method, rather than calling the real code associated with this class, just return some fixed value or something. And then you can also confirm that methods were called on that mock. There's a bunch of mocking frameworks out there. My favorite is Mockito. So you can look at that further if you want. And that basically gives us exactly what we want when we're doing these browser sorts of tests. We need a way to get fake instances of our widgets and of our server, and to confirm that they were used in the way we expect. Just using Mockito and trying to apply that to your GWT test isn't going to be enough, though. And the problem you're going to run into is that you still have these GWT-specific sort of issues, like when you try to call GWT.create, you'll get those exceptions. So a library that I've been working on and that I announced at Google I/O this year is one called GWT Mockito, which actually bridges the Mockito world and the GWT world such that they work nicely together. So by using GWT Mockito, it'll make it so GWT.create works and returns mock objects. You get mock UI fields and so forth. And I'll give you an example pretty quickly of what a test written in that style looks like. Before I move on, I want to say a little bit about MVP, though. So MVP, as you might be aware, is a really popular pattern for writing GWT applications where you split all of your components up into a separate view and a separate presenter. And the idea is you isolate things like your scary DOM code off into the view to make it easier to test the presenter. And this is really valuable when you're doing something like you want multiple different implementations of views, or you have a lot of very interesting view logic you want to isolate. But it turns out that in a lot of simple sorts of widgets or simple sort of pages, it can just be overkill. So if I look back at this form, if this simple widget here, if I wanted to make it more testable, I could potentially factor out an email view which contained these widgets and then had methods for manipulating them. But what that looks like basically is I just have kind of the same class duplicated over again with 2 fields in it and a couple methods just to pass through and make one-line calls on those. And so that ends up just being a lot of boilerplate. And the idea of doing that is to make it easy to mock the view. My viewpoint is that if you can mock the view, why not just mock these widgets directly? And that saves you a lot of overhead of defining extra classes here. So MVP is not bad. You should use it when you need this extra flexibility, but it's not something you need to use just to completely isolate yourself from the widget world. So let's see what a test actually looks like using GWT Mockito. So here's a simple test with 2 basic test cases I'm going through here. So the first test is saying when I type a valid email address into that field and the user clicks save, then I should show the success method, the success message. And the second test is saying if the user types an invalid email address and clicks save, I shouldn't communicate with the server at all. And let's step through each of the various components of this test to see what it's doing. So first thing to notice is that we've annotated the entire test with this run with annotation, and we're telling it to use the GWT Mockito test runner. So run with is a construct in JUnit 4 where you can basically tell your application, tell your test what it should use as its like underlying test runner, which can do lots of various things. So here we're telling it to use GWT Mockito test runner, And that's what's going to link in Mockito and tell it to perform all these magical steps. So the first bit of magic you'll see is that we have this email service here that's annotated with the GWT annotation. So once you've applied the GWT test runner, it will say that anytime you call GWT.create, instead of failing with that big scary exception from before, just return a new mock object that you can then program however you want. And what the GWT annotation here says is also populate this field here with the same object that gets returned from GWT.create. So the end result of these two things here is now back in my original code when I create my service. It's going to be created as a Mockito mock, and this field here will refer to that same mock so that I can program how my service works. And then you can see here inside my test, I'm actually programming what's happening on this service. So this is syntax from Mockito here that tells me how this mock should behave when you call the set email address. So what it's saying is when you call set email and pass it any sort of arguments, then you should asynchronously return success immediately using this async success method here that's defined by GWT Mockito. And so this will mean that whenever you call set email, it'll just immediately invoke this success handler. It won't wait to go through any sort of server call. It'll just call success immediately. So you can pass additional arguments to async success there if the success handler requires them. You can also use async failure to test failure cases. So this together will allow you to basically program how your server will respond in any given case. And you see I'm doing kind of the similar thing with widgets here. So in addition to mocking the results of GWT.create, GWT Mockito will also automatically populate all UI fields with mocks. And it does that by returning a fake instance of a UI binder that just uses mocks for all UI fields. So once I've done that, recall that it's necessary to declare UI fields as package private so that UI binder can reference them. And that has the nice side effect of saying I can also reference these directly from my tests. So the first line in each of these tests is setting up the getText method on my text box to just return a fixed value. So now rather than looking into the DOM for some text that the user has typed, we've just programmed in each case, just assume the text box returns this value when you try to reference it. And then later on, we can perform a verification against that same text field. And we can say that in the case of this first test, once everything's done, we want to go through and check that you actually set the success test onto this message here. So with these mock objects, when you call methods on them, they won't actually do anything aside from record the fact that they've been called, and you can check them later in your tests. So end result here, this test is saying, assuming that the text box returns me@foo.com from its getText, and assuming that the server returns success, then when you call the save method here, the label should be updated in this way. And that's almost it. The one last thing that's worth noting here is how I'm calling this click handler here. So it's pretty straightforward. Since this is just a normal Java method, you can basically just invoke the method directly, and that's pretty much the same as clicking a button. The one little detail you need to know if you're writing these kind of tests is that you can't actually instantiate click event directly because its constructor is declared as protected, which keeps you from creating a new instance. So the little hack you use to get around this is to append these curly braces after you call the constructor. What this is actually doing is it means that rather than creating an instance of click event itself, you're actually creating an anonymous subclass of click event. And since you have an anonymous subclass, that is then allowed to call the protected constructor. So it's just a little bit of ugliness that you need in order to test with these events, but it's not too bad. Another option you have is to use mocks here. Mm-hmm.
Can you also simulate key events?
Yeah, so in the same sort of way, if there was an on key pressed event here, you could create a fake key event in the same way. If you want to be able to control what is returned from those events, like control like whether the shift key is down and what the actual key is, then what you can do is you can actually create a mock key event, and then in the same way you're programming these widgets, you can program the event to say that when event dot is shift key down, then return true. Similar sort of thing there. So this will actually get you most of the way in terms of what you need to do in writing your tests. This basically defangs GWT.create. It says when you call GWT.create, nothing will die horribly. You'll just get these mocks and all these difficult parts of your that would normally make GWT hard to test. You can control yourself. The one big problem remaining that makes GWT applications hard to test is JSNI. And JSNI is going to be a much bigger problem for us. So as you're probably familiar with, JSNI works by defining in your Java code a native method and then using a specially formatted comment to provide JavaScript to implement that method. And then at GWT compilation time, the GWT compiler will go through and turn that comment into actual JavaScript. So what we said our goal with using these Java tests is to test our application just as if it were a normal set of Java classes without the GWT compiler at all. And so, of course, it's going to be really hard to test these actual JavaScript methods. There's a few strategies you can take. First thing that GWT Mockito does to help you out is to stub all these native methods. So normally, if you tried to invoke one of these native methods inside your test, you would get another big scary failure saying undefined link error. We don't have any implementation defined for this thing because it's just defined as native. And that would kill your tests right away. We don't want that. That's a big problem. So what GWT Mockito does is it basically generates fake implementations for every native method that your test encounters that just do nothing and return an empty string or a 0 or some uninteresting value. And this actually helps in a lot more cases than you might think it would. A lot of the time, when you're using a native method or when a widget you're depending on is using a native method, it's not something that's core to its functionality, but it's just something that's like maybe adjusting a style or something you couldn't normally do through the normal GWT APIs. So that by stubbing these out, most of your widget still continues to work. Of course, there are plenty of times where the JavaScript code you're depending on is actually important and has to do things. So there you need another strategy in order to fake out this JavaScript. Best choice typically is for you to take advantage of dependency injection. And so what I mean by that is that usually when there's a blob of JavaScript inside of one of your widgets, that JavaScript represents some sort of interesting standalone task that could exist on its own. So if you can factor out that JavaScript into its own class, move all the native methods there, and then inject that class into your original class. Once you've done that, your test can then provide a mock implementation of that class and use it instead of the JavaScript. That way your test can basically re-implement whatever that JavaScript needs to do. That's usually the most robust strategy you can take. Another option you have, just as a quick hack, is to actually override native methods directly in your test. So this is a bit uglier, but you're saying that if I have a class called myWidget and inside it has a native method called doJavaScript, then in my actual test code, rather than testing myWidget directly, I can test a subclass of myWidget that overrides this native method and does something like either track that the method has been called or take some sort of fake action. And this works. It's not a great solution. It's a little bit ugly. It doesn't work if the doJavaScript method is private here because you need to be able to override it. So usually you're better off using dependency injection, but this is an option that is available to you. And of course, at some point, you're going to want to actually test all that JavaScript you've defined. And this is where you need to fall back to using GWT.TestCase. Because at that point, if you're trying to execute actual JavaScript, that's really what GWT.TestCase is good at. So you shouldn't feel bad about doing that. My only point here is that you shouldn't use GWT.TestCase just because some small part of your widget happens to use JavaScript. In that case, the better thing to do is to have a to test 99% of your widget using normal fast Java tests, and then rely on GWT test case just to test that one little bit of difficult JavaScript code. That way you can get the full benefits of quick, easy tests for almost all of your application, and use the slower GWT test cases only when it's really necessary. So let's summarize real quick what I talked about GWT Mockito and unit testing. So GWT Mockito is easy to install. All you have to do is annotate your test with this run with GWT Mockito test runner, and that'll tell JUnit that when it runs the test, it should do this magic stuff. That magic stuff does is it means that all of your calls to GWT.create, instead of dying with exceptions, will return you either a mock object that you can program later or some specially defined fake objects. Most important fake object are these fake UI binders that go through and populate all your UI fields with mocks. So big thing that GWT Mockito does is everything that would be scaring your application is now just replaced with a mock that you can program to work however you want. Last couple things GWT Mockito does is it goes through and replaces all these JS&I methods with no ops, such that if you depend on some class that happens to use JavaScript deep inside it, you can keep testing it without just dying immediately. And it also goes through and removes final modifiers from a lot of cases. And this is actually important because if you're using something like a JavaScript overlay type, you have the problem where all of your methods inside a JavaScript overlay type have to be defined as final. Normally, mocking frameworks don't allow you to mock final methods because they're not able to actually go through and override them. But using GWT Mockito test runner, it actually modifies the bytecode to remove those final modifiers so that you can test with those. So it doesn't usually come up, it just kind of happens silently in the background, but that's another problem you might have if you were not using GWT Mockito. That's about it for unit testing. So for the second half of this presentation, I want to talk about functional tests and some strategies for writing them. So as I said before, functional tests are not just larger sorts of unit tests that test more classes. They're really a fundamentally different sort of test. So with a unit test, you're going through and thinking like a programmer would. You're saying, okay, if I call this method, I expect this result, or I expect this side effect. Functional tests are very different. They actually work like a user would and go through and say, okay, click this button, type into this text field, open this menu, and then verify that I see some result on screen. And the most popular strategy for writing these sort of functional tests is to use Selenium and WebDriver. And these are big open source projects. How Selenium and WebDriver work is they provide you an API to interact with an actual real instance of a browser. So when I run a Selenium test, it actually starts up a browser and goes through and actually clicks around and reads what's inside it. And these kind of tests are very valuable to have because they're completely independent of the underlying implementation. So I found that a lot of the time when I'm working on my application, I decide that I want to go make some deep changes internally about how it's structured in order to improve performance or make it easier to work with or whatever. And I might go through and replace a dozen different classes inside it, make some vast changes, change the entire architecture. And in doing that, I've basically completely invalidated all my existing unit tests because the classes they were testing might not exist anymore. And so once I've done that, I will go through and run my functional tests. I'll see that the first time I do it, my functional tests probably fail in a dozen different ways because I made some small mistakes. And I'll go through, fix all those errors, and then at the end, I can be very confident that my application worked the same way as it did when I started. And without these functional tests, I would not be able to perform those big refactorings at all because I would basically just be too scared that I would be breaking something subtle and I would have no way to fix them. So that's really the value these functional tests provide you. You can make huge changes. Like if you've done your functional tests correctly, you could even say rewrite your application from GWT and change it completely to Angular or some other sort of implementation, and your functional test would keep working. So that implementation independence is really the value you get out of them. There's still a question in functional tests on how much you should be testing, specifically whether your functional test should also include all of your servers or whether you should fake those out in some way. My general view on this is that you always want a few tests that start up your entire world, start up your server, start up your database, run completely end-to-end. But doing this can take a really long time. It might take even 10 minutes to run such a test, so you generally only need a few of them. Mostly you can get a lot of benefit from mocking out your backend in your functional tests, so you just test your UI. And so, like I said, the real value is you're testing as a user, you're verifying that it actually works to a user, end-to-end completely, not just a single method inside your test. So let's talk about actually writing these functional tests and how you can try to make them readable and maintainable. The most important pattern you have to know about when you're working with functional tests is what's called a page object. And a page object represents either an entire screen in your application or some sub-area of that screen, some sub-object that is reused across multiple pages. And you might think this sounds very much like a GWT widget. It's the same way to factor out common pieces of functionality, and you'd be totally right. The difference between, and usually you have your page object and your widgets mapping one-to-one in direct correspondence with each other. The difference between a page object and a widget is that when you have a widget, as you know, it describes how to actually implement this functionality, describes how to work with the DOM, and so forth. A page object, however, is focused solely on the user and provides an API that describes how the user interacts with this widget. So a page object might have a method like click this button or enter text into this field or look at a result. And so these page objects are not something that is run as part of your GWT application, but something that are run as part of your tests in order to abstract out these implementation details. Just like widgets, page objects can be hierarchical. So if you have a widget that contains other widgets inside it, then you probably will have a corresponding page object that contains page objects corresponding to those widgets. And what really makes a page object interesting and kind of defines it is that it is very structured in what sorts of objects it returns from its methods. And a page object really has two different types of objects, or two different types of methods. Either input methods that allow the user to interact with that page object, or output methods that allow you to look at that object, see what state it's in, and perform assertions. And so for these input methods, each input method will always return another page object. And the page object it returns represents where the user should be after taking this action. So if there's no screen transition, if by, say, typing into a text field the user doesn't go anywhere, the page object just returns itself. If there is some sort of transition, then the page object will return another page object representing where it went. And I'll show you examples of what this lets you do soon, but the rough idea here is that this allows you to chain together your page objects in a very powerful way. And then output methods, they'll return a string or an integer or something that allow you to perform assertions in your test later. So let's run over a quick example of how you might define the page object in your application. So this is the application I work on for Google Wallet. This is basically on the Play Store. If you want to go through and buy Angry Birds or something, you click the buy button. This window pops up and it allows you to choose your payment method and confirm your purchase. So here, this is one page in the application. It doesn't have very many controls or sub areas inside it. So probably here I would just define a single page object, and it would have 3 methods for interacting with this thing. So it could have a click close button to click that button up at the top, click buy to click the buy button down at the bottom, and then another button to click this instrument selector and open it up. So let's say the user goes through and opens up that instrument selector. They'd see a little pop-up that looked like this. So inside my application, I would structure this as another page object that lives inside my main page object and has more methods for clicking each of these various rows. Say the user clicks the add payment method, they'd be taken to this credit card screen. And so here we've reached something that actually has some more interesting structure into it. Inside my GWT application, I happen to have structured this using 2 different widgets, one that represents the credit card fields up at the top, and one that represents the address fields down at the bottom. So when this is broken into page objects, I'd have one big page object containing the whole thing that had methods for clicking on the save and cancel buttons, And then I would have page objects for each of those individual widgets in the form that would allow the user to interact with that form. So what does a page object actually look like? Here's a basic implementation of the last page I saw with the add credit card form. And I have one of each type of method I talked about earlier here. And you can tell what type of method they are by looking at the return values. So in the very first method, I have one that allows the user to fill out the credit card field. After doing that, they aren't going to change screens in any way, so the method just returns the page object itself. Next method allows the user to click the Add Credit Card button, and so that return, which is going to take them back to the original page, so it returns a new page object representing the review purchase page. Third method is one that actually looks at some property of the page. So here I'm checking to see if there's an error message, getting the text associated with it, and returning that text. So this would allow me in my test to check that an error message appeared as expected. And there are a few interesting things to note here. First thing you might see is that I'm using kind of this strange strategy for getting references to these elements. So WebDriver provides a lot of different ways for you to figure out basically what is this element and find it and get a reference to it. The most direct is just going to say find an element by ID and then interact with it in some way. And that's just by using like the find element method on WebDriver. This sounds straightforward, but it's actually something you almost never want to do. So the problem here is that as GWT developers, we tend to write applications that are very dynamic and very asynchronous in nature, such that whenever the user takes an interaction, there might be some delay. You go talk to a server, you go run some asynchronous JavaScript code before you actually show the result. And the problem there is that what happens if when you try to get that element, it isn't present yet because you're waiting for the server to return? Well, then normally WebDriver would just fail in that case. It would tell you that you're trying to look for an element that doesn't exist, and you get an error. And the big issue here isn't just that your test fails, but that it might only fail a small percent of the time. So maybe 99% of the time, your application runs quickly, the UI renders instantly, and you can proceed normally. And it's only 1% of the time that the network or your application or something is slow enough that that's not there in time. So a 1% failure rate might not sound too horrible, but if you're writing a lot of these tests, if you have 100 such tests in your application and each fails 1% of the time, that means that you'll basically have constant failures in your application. You'll never be able to run it successfully, but any individual error is going to be really difficult to track down. And this can be an immensely frustrating situation that I've been in plenty of times, so you want to avoid doing that. There's a few ways to work around this. The most obvious might be to say, okay, every time before I look up an element, just throw like a thread.sleep in there for 5 seconds. That will work most of the time, but it's going to slow your application way down, slow your tests way down. Most of the time, your element's going to be available in a couple hundred milliseconds at most. So if you add 5-second waits between each of those, it just means your tests will take forever, which is sad. So what you should do is take advantage of the wait functionality that's built into WebDriver. So when you tell a WebDriver to wait for a condition, like for this element to become present, WebDriver will basically poll and say every 100 milliseconds, check to see if this element has shown up. And if not, just keep polling. And then maybe only after a ridiculously long time, like 30 seconds or so, will it time out. And that really gives you the best of both worlds, because it means in the normal case where the element renders after 100 milliseconds, you run quickly. But if there happens to be a small delay, your tests won't fail. They'll basically keep working. So the moral of the story here is never try to look up these elements directly. You always want to wait for them to become available. And that might have sounded like a tangent, but I guarantee you that when I started writing these tests, I started off by trying to look up elements immediately, and I didn't think this was a big deal, and it just ended up a huge headache later on. So try to save yourselves that heartache. The last thing I want to point out on this slide is how we're actually referring to these elements. So you can see here that I'm always referencing elements by ID. ID tends to be a much more stable way to refer to these elements than using XPath or using CSS selectors. And I'll go over why that is and the strategy I use to construct these IDs in a little bit. But you can see here that basically it works by concatenation. Each page object knows the ID of the element it's responsible for, and to look at its children, it concatenates that child's ID onto its own. So again, I'll go over that in more detail soon, but just keep in mind for now, we're referring to elements by ID. And so let's see what a test actually looks like in the end once we've written these page objects. So you can see that this looks actually quite a bit different from a normal unit test. Like I said, with a normal unit test, you're going through and you're calling the functions in your application, and you write something like as a programmer would. What this looks like using page objects is something that reads much more like a script that describes what a user is doing. So I can basically just read this test aloud almost. I can say that starting at the merchant page, you go through, you click the buy button, you open the credit card selector, you select that add credit card option, you go through, fill out some fields in the form, then you click the add credit card button, and opening the selector again, you can see what's there and confirm that it's equal to some value. So here we're testing that whole add credit card flow. And this might seem a little magic that you can just write it out as a script like this at first, but the reason it works is that you have these precisely defined return values on all of your page objects. And I've annotated over on the side here what each of these is actually returning. So again, starting with the merchant page, when you click the buy button, since that's going to take you to the review page, it returns this review page object. And then on the review page, there are several actions I can take, one of which is opening the credit card selector. That will return the selector page, and so on and so forth. So what you end up here with is this very strongly typed sort of test. And that's valuable for several different reasons. So first reason this is valuable, as you can see, is that it makes the test super easy to read. You don't really even need to be a programmer to describe what's going on here. Second advantage is that it makes your tests very easy to write. So as I'm writing this test, if the page objects have already been written for me, because they usually only need to be written once per widget, I don't even need to think about what underlying page object is happening in each intermediate step here. I can basically just ask my IDE via its autocomplete functionality what I can do next. So on the merchant page, I can hit Control Space in Eclipse, see what functions are available. Okay, I want to click the buy button. Now, not even knowing that that necessarily took me to the review purchase page, I can ask it again, okay, what can I do here? I could click the buy button, I could open the credit card selector. Okay, let's open the credit card selector. And then that takes me to a new place. So I can keep just auto-completing in my editor here and just write these tests in a very natural way. The final benefit to this type safety is that it gives me a very early warning if I've changed something in a way that isn't legal. So if I refactor my application such that clicking the add credit card button here doesn't take me back to the original review purchase page, and then update my page object to reflect that, the fact that I've changed the type that it's returning means that all my tests will be broken immediately just because the types here will no longer be valid. So that means that I don't even have to run these functional tests to see that I've made a big change that's going to cause a lot of problems in my application. So in that way, they can kind of even be faster than a unit test, just because I immediately get these type failures and don't have to run them. And to reiterate here, the big point, the reason this works is that inside my tests themselves, I'm never referring to WebDriver APIs. I'm never referencing DOM elements directly. I'm only speaking in terms of these page objects. And that encapsulation is what makes this work. So a lot of people, when they try to write these kind of tests, the individual test will go through and reference the elements directly. And so you can see here that if I was doing that, if I was directly looking up elements to type into for the add credit card form, that would break if I ever made any changes. So for example, if I changed my page structure such that the fields were in a different order or had different IDs or were contained in different elements. That would, if I wasn't using page objects, that would cause all my tests to fail, and I would have to go update everything in the application, every one of my tests, in order to reflect these changes. Whereas here, when I change the implementation of my widget, all I have to do is change its one-page object that describes how to interact with it, and as long as those fundamental interactions stay the same, I don't have to update my tests at all. So everything I've been talking about so far is not really GWT specific in any way. These are just good practices for testing a web application. I want to close off with just a few more things describing some GWT specific tricks that can make your application more testable. How much time do I have left? Okay. Okay. So one thing I mentioned earlier is how you actually need to figure out how to refer to these elements. And there's a bunch of different ways to do that, and I'll just kind of describe my strategy here. So first, as I mentioned, you should always refer to your elements by their IDs. WebDriver provides you a lot of different ways to refer to elements. Like some other alternatives is to refer to class names or to refer to XPath. And so XPath basically says, I want to find a div inside another div and then take like the second span inside that. That ends up being very brittle because it means that any sort of change you make in the structure of your application will cause things to break. IDs, basically, you have no reason not to use them in GWT. IDs are the most powerful because as you move items back and forth on the page, as long as the ID stays in one place, you can just keep consistently referring to them. There's still an interesting question of how you actually define those IDs, though. So the strategy I use is to define IDs hierarchically. So if I have that address form on my page that has a zip field inside it, I don't just give it a single ID called zip field or whatever. I give it that ID, but then prefix that by the ID of all of its parents. So you can see that causes it to, so if it's inside the billing address field, it's billing address.zip. If that's also inside a credit card form, it's credit card form.billingaddress.zip, and so forth. And the example to doing this is that it keeps all of the IDs in your application unique. So suppose,
But if you're building components which are being reused in other applications, this wouldn't work.
I'll describe how to get this working. So I don't specify these manually. These basically are automatically, these IDs get automatically constructed using GWT's debug IDs. And so the reason you do it this way is for this reuse. And so different forms don't conflict with one another. So say I had multiple address forms on my page, both a billing address and a shipping address. If I was just using fixed IDs like zip or whatever, then I would end up with two elements that had the same ID, which is not allowed. But if I'm using this strategy, then my second form, if it's called shipping address, it was otherwise in the same place, then the zip field there would end up being bypage.creditcardform.shippingaddress.zip. So the particular structure there doesn't matter as long as that it's unique. And using this strategy also makes it easy to index into these IDs and figure out what the IDs of your children are just by doing this concatenation. So if I'm writing a page object for this billing address form, and I want to figure out what the ID of my zip child is, all I have to do is take my ID and append the child's ID to it. And then, without knowing what all my ancestors' IDs were, I can figure out what the ID of that specific child is. Important detail here is that you should only be referring to your children, not ever to your grandchildren. And that makes sense from an encapsulation kind of point of view, where if you have a widget, you're only allowed to directly refer to the children of the widgets that you contain, and not the widgets that are inside the widgets you contain. So for example, my credit card form is never allowed to look directly and modify the zip field itself. It's only allowed to talk to the page object for the billing address, which will then modify the zip field, which is exactly the same thing you'd do if you were working with widgets. Obviously, these IDs can get pretty long, especially if you have a big application with a bunch of nested components. So you might not want to expose these IDs in production just because it's extra code size and it kind of exposes your internal structure. If you're using debug IDs in GWT, there's basically just one line you can include in your GWT.xml file, which will tell it to completely compile out these IDs. So that means during production, you won't have anything in your when you run in production, you won't have anything at all. And then only when you're running in test will you actually turn these IDs on. And so let's talk about how to actually get these IDs set up automatically in GWT, which is the question that was asked a little earlier. So this here is taking advantage of this debug ID functionality. Oh, and this is really the kind of the other direction of how the page object looks things up by ID. So how this works is that each widget has this onEnsureDebugID method that is invoked whenever that widget's ID is set, either directly or through UI binder. And then it goes through and on each of its child widgets, it propagates that debug ID down by appending some ID for that child to the base ID. So what happens here is that when I set the root level ID on this credit card form, say I set it to credit card or something, then it'll go through and set credit card number's ID to credit card.card number. And if the credit card number widget then has additional children inside it, that'll cause it to continue to propagate down, and you'll end up with this ID of this tree of element IDs. So at the root level, you only need to set up this one ID, and then as long as you have these IDs inside them, they'll continue to propagate. And what's really driving these here is this IDs class, which is shared between your widgets and your page objects. And this IDs class basically is just a set of strings that identifies each of the unique IDs in your application. And the fact that this IDs class can be shared between your test code and your application code is kind of a powerful advantage you get of using GWT. That means that rather than having to keep some JavaScript ID code and some test code in sync, if I discover a problem in IDs here, like if there's a duplicate, I can go through and just change the ID and it'll affect it in both places, which is pretty nice. And then the last thing I wanted to talk about in my few minutes here is this question of stubbing servers. So like I said, you usually want to run a few tests that run end to end, but for the most part, it's great if you can stub out how your servers actually work and give them fake values so your tests can run much more quickly. There's a few different ways to do it. This is my strategy here. So at some level in your application, whether you're using GWT-RPC or whether you're using Request Builder or just constructing a request directly, you're going to have something in your code that calls down to the server to actually make that RPC. So what you have to do in order to make this testable is to factor out this sort of server connection interface, which allows you to provide both a real and a fake implementation of this connection. So here, the real connection makes an XHR. And in my stub connection here, I'm instead just reading from a global JavaScript value in the page. So rather than making a call down to the server, read from this variable, invoke the callback directly, and then I'll just need a way to configure that variable inside my test. And then I can use deferred binding in order to decide which of these implementations to use. And that's with a rule that looks like this. So if you've never used deferred binding before, this might look a little intimidating, but it's actually not too bad. So how deferred binding works is it basically allows you to define compile time variables and then to take action based on those. So what I'm saying here is I'm defining a deferred binding property called server type, which can be set to the values real or stub. I'm going to set it to real by default, and then I have these couple of rules here that say, okay, when the server type is set to real, then I want to replace every instance of server connection with the real server connection. And now below, when it's set to stub, I want to replace every instance of server connection with stub server connection. And this is pretty cool because it means that when I compile my application normally, none of this test code will get pulled in. The compiler won't see it at all. But then when I set this flag to set server type to stub, I'll compile with this fake version of the server. The real one will go away, and now I have this one that reads from the page that I can control. And here you can see in a test what this looks like. So here I have a test that's testing something like Gmail's autocomplete feature, where I start typing a name into an address field, and it should show me my contacts that match that name. Normally, that would require a call down to the server to load that contact data, but in this test, I want to stub out that functionality. And so what I do here is by defining this sort of stub server object, which works kind of like a page object in that it encapsulates interaction with WebDriver, except it is, rather than interacting with an object on the page, it's just representing the server. So when I go through and call set contact data on that fake server, it goes through and runs this little bit of JavaScript through WebDriver to actually assign that variable to the global variable I defined earlier, assign that data to a global variable I defined earlier. And then when I run the test, I just proceed as normal. So the end result of doing this means that when I run my test and start typing in the recipients field here, I'm testing my application just as I would normally. It'll go through and execute all of its normal code, and then at the very last moment, when it was about to make a call down to the server, it'll instead just read this JavaScript variable and return back to my application directly. So it'll run very quickly. There will be no server call. There's nothing to start up. It's completely stable. And so by doing this, I can get a test that in many cases actually builds and runs almost as fast as a GWT test case, because it's still going through and doing the same sort of GWT complication of my application. It's going through and starting up a browser, except I have this much more realistic test here that actually tests end-to-end like a user would. So that's another reason that I prefer using one of these sorts of strategies to GWT test case. So let's sum up real quick the tips I gave for writing functional tests. So first, you should always be referring to elements by ID. You should never be using XPath because ID is a lot more stable. You always want to wait before you look up an element. Never perform an assertion that element is there immediately, and never sleep. Always wait so you can get your minimal latency. And there's this class inside WebDriver that gives you some conditions you can wait on. In your page objects, you only ever want to use one level of dereferencing. Only look at your children, never their grandchildren, because that would break encapsulation like you'd expect. Inside your tests, all your interaction with the page should be through these page objects. They should encapsulate all your interaction with the DOM. That's what allows you to have this flexibility and resilience. And then the last thing I showed you here was how you can kind of use this API. Use this JavaScript API to expose a backdoor to your test. So I gave an example here of how you can use this to stub out servers. You can actually use this as kind of a more general technique, where you say maybe as part of your normal application code, when something happens, write to some JavaScript variable, and then allow you to read it later in your test. So that can be a useful way to test things that don't have immediately user visible impacts. You want to be careful not to go overboard with that, because the real benefit to these sorts of tests is that they allow you to test it like a user would. So that can kind of defeat that purpose, but it's an option that's available to you based on what sort of things you want to test. So that's really all I have. Please remember to rate this session at GWT.create.com/agenda. I've linked down here to the libraries I talked about in the session, and you can find me on Google+ or on GitHub. I can take questions now. Mm-hmm.
How would you integrate these tools into profiling? Could you use these tests to profile your application
to see how quickly it runs? Profiling is not something I've experimented with a whole lot. Typically, so GWT Macchiato definitely wouldn't make sense for actually profiling the end-to-end speed of your application, because compiling to JavaScript is going to give it much different performance characteristics. I haven't experimented much with integrating into Chrome's profiler. I believe Chrome actually exposes an API for the profiler that's built into there, so you probably could write a WebDriver test that looked at the output of Chrome. Yeah, I suppose you could expose a page object that talked directly to Chrome's profiler API, so that's something that would probably be cool to do, but I haven't experimented with it. Mm-hmm.
I want to ask a question about GWT Macchiato.
Mm-hmm.
Do you plan to use standard Macchiato notations for your test cases? For
example, inject mock annotation would be very useful to inject the mocks widget mocks to GWT.
Yeah, so GWT Mockito isn't a re-implementation of Mockito. It depends on Mockito and pulls in the real Mockito implementation. So GWT Mockito itself is actually a fairly small wrapper that just stubs like GWT.create to fall back on Mockito. So any of your normal Mockito patterns, those should all basically work. So like the @mock annotation, if you use that, it'll keep working. So yeah, anything you're doing with Mockito now, you can keep using during GWT Mockito. There's nothing new to learn there.
Yeah, so in your example, you referenced the widgets from the testable class. Yes, so you written field.widget.setMessage, for example. So can you pull this widget to a mock object in the test case, mark it as annotation mock, and then reference it instead? So will it comes to GUI binder and inject it to the
Yeah, you can definitely do that. So yeah, if your widget has injected dependencies, then yeah, it's very normal to define mocks inside your test and inject those. Yeah. So GWT Mockito automatically fills the UI fields, but if you're using your own normal mocks, that'll keep working.
Regarding the functional tests, you said that you set the IDs used for automating the test. You set them manually, but shouldn't it be possible to somehow automate that? Let's say if I'm using the UI binder framework, then I have these UI field IDs already. I should be somehow able to reuse that. Is there a possibility to do that?
So how UI binder works is, yeah, there's the UI field property that lets you assign it a name in the GWT, but you can also pass a debug ID in UI binder. As far as I know, there isn't any particular way to make those things shared, and it might not even make sense, like if you had multiple fields with the same name across different UI binder files. You do need to make sure that those receive unique debug IDs. So I found that it generally isn't really any additional burden at all to just say at the root level, this is what my debug ID is going to be. And you only really have to specify that at like the highest levels of your application. And then as long as you have your widgets automatically propagating IDs, that'll continue to work.
Does GWT come with any support for timers or deferred nodes?
For timers? You mean like using a scheduler with like callbacks? Yeah, so it will create mock schedulers, and then you can basically, so you can either inject a fake version of your scheduler and then control it as is, or you can just refer to that mock that's been created and then tell it to automatically invoke the things that have been called on it. So yeah, I've used that before and it should be supported.
It doesn't bring its own single-threaded JavaScript explanation.
No, it doesn't. Yeah, and I think I'm out of time. So I'll be up here to answer any more questions afterwards. Thank you.